So that was a pretty easy question, I guess.
Yeah, so then for like the core idea behind graph rag is just to organize information as a graph or traversals, obviously. So let's go to the next question. Obviously, this one is still quite simple. So it's like the graph rag is basically targeting like random answers or multiple connections. So that was the main beneficial thing graph rag was the main goal of graph rag. So Microsoft's graph rag, like and check the previous slides, but basically the papers trying to build a hierarchical community summons and they use some previous techniques at query time. And the others they are bit of mistaken. Oh, who's the rag god?
That's me.
Okay, somebody online. Great. Which subset?
For like structurization is the one that formalizes the graph. So decomposition is more for like splitting the task, and then extension is more like following the edges of the graphs. And then the verbalization is more about how the text itself is crafted. So the correct answer to this verbalization.
So you mentioned verbalization, that's not an
Oh,
option
sorry.
yet, right? So,
What's in my previous version?
okay. No worries.
Oh, congrats. So in molecular, so basically the retrieval in molecular proceeds in two different levels. So there's this one low level retrieval and one high level retrieval. So to give some more concrete samples, since like for low level retrieval is more targeted, such as if there are more entity or relation specific queries, such as like what is the relationship between that's for like those high level retrievals, so there are more abstract or thematic queries. For instance, like how does AI influence the education in the current era? So this one is broader, and then that involves aggregating on multiple edges for long graph. So then the results, like the correct answer here would be to drop community summaries and to use two generated keywords, one more targeted and one more abstract. by definition is a community finding or community detection algorithm. So the goal of community detection is trying to maximize modularity and measure how well the network is partitioned in the communities. So that's the correct answer of the modularity. Oh, the record is back. Then the last question. Here for organizer and generator, so the role of organizer is mainly filtering and packaging, whereas the role for generator is more in how answers are produced. So here, because like somehow like Kahoot doesn't allow a lot of text to box. So here discriminative and graph they refer to the 3 ways for using for producing answer. One is based using to produce the answer. One is discrimination based, such as using non-generative models like Jiecheng or Jiaying transformers that can some sort of say classify or rank. And then for graph-based approaches, so they will just generate directly from the graph's own representation without relying on Gaussian neurons. So those three like correlate the 3 key points. So this summarizes our quiz. So a round of applause to the
At the last minute, I got and Chris. Okay, congratulations. Thanks, Jiaying, for narrating and creating our quiz today. And with that, I think our first presenter is online. So we can see whether. Yeah, you can direct. Yes.
I'm just curious, week 13, right? I mean, there'll be a Kahoot after that, right? So there's no week 14. So
There's only 14. Yeah. So what we'll do is we'll run Kahoot at the very end of lecture.
Okay.
Yeah. So those of us, whoever is running in creating the Kahoot for 13 actually needs to work with the lecturing staff to prepare the Kahoot at the same time. So yeah, I will try to message it on the week 13 prep that we're clear at that. Okay, we'll stop our screen share. I think our online participant, Yisong, is
Yeah.
away from
Hi, everyone.
presenting all the way. Right? So take the screen share when you're ready.
Oh, yeah. So before screen sharing, I'd like to say hi from Barrett also. So Barrett is hi. We're here at the conference, but we're both busy with our group duties here. Yeah. So yeah, great. Okay.
And
I'm
you
going to share
both
this.
for working very hard while doing work at NLP, which is a top-ranked conference in NLP. So yeah.
Okay. Can you guys hear me? And see the screen? Everything good?
Yes.
Okay, yeah. So I want to apologize in advance if that I have to have some 30 seconds interruption because I see the securities they're trying to push us away. So I'm trying to hang here. Okay, right. Okay, so I'd like to first give a very quick intro of this session. So then I will leave the floor to my colleagues real quick. I'll go through the introduction, and then we have this agenda of then I'm going to talk about provenance, Nikhil talk about credibility, Zihang about pluralism, Jiecheng on factuality, and Aaron on uncertainty, and finally Jiaying will close the session and also give a lot of credit to Jiaying because she was the one helping creating this agenda today. So yeah, we have an amazing agenda today. So so my part is actually very easy and it's very intuitive. So the idea is that so when we are tracing the source of the we're tracing the source of the news. We're trying to guess the credibility, whether we can trust the source of the things we are referring to. Is it really trustable? Like, it's like we put in a small dough into a bigger dough, then a bigger dough into a larger dough. Yeah, can we trust them? So here, I like to share the quotes from my internship advisor, Dr. Very Schwartz. So she wrote this one, like simple examples for how errors can creep into our papers through LLM use. I had something in 2020. I Googled the same stats for 2023. AI overview talk about, listing is from 2023 because it only provides a link to support the claim. So it's sort of like the credibility can be like refreshed by just iterating, by just talking about it, by just iterating year by year. And we still believe that the thing is quite recent, but in fact, it's not that recent. So as the first figure tells here, right? We just put a small box into a larger box, but the core of thing hasn't got updated. And the statistic for 2020 should also be probably updated. So this is the general idea about the temporal awareness about source credibility. So this one is very interesting. And I also like to share another thing about like the false negative things in the source and the things that we cite. That idea is that there could be something we should cite and we should have, but unfortunately, due to some reasons, the citation doesn't come as expected, and there's a false negative. So here, I like to quote a conversation between me and my advisor, Prof. Ming. We were at a lunch meetup with a staff, a lady from the Elsevier publisher, and they told us that it's very hard to track citations to do a really good literature review of a field, because whenever we read the RW section of a work, they cite a few papers. However, there are always some missing citations. So like here are two robots that say, I don't want to cite your paper. And the other robot said, I don't want to cite your paper either. So it's like, the two robots, they don't like each other and they don't cite their papers, but they worth being cited. So however, when someone's paper got prominence later, so people will believe that their related work section is pretty well, and they will probably just ignore the proper citation that really needs to be properly cited. So here's a false negative example. So I think the example one is the false positive because we think it's recent. And example two is a false negative signal that things should be there, but it hasn't been there due to some reasons that's among human, not really about machine. Okay, so thanks to our lecture coordinator, Jiaying, today. I get to read this amazing survey, and I would recommend everybody in this room to read this survey because it basically like a root or umbrella for today's reading group. So, and the authors have brilliantly classified the trustworthiness in RAG system into these 6 types: robustness and privacy in the generation. In the retrieval stage, and fairness and transparency in the generation stage, and factuality and accountability in the checking stage. So yeah, we have this triangle here, and different components being evaluated in different stages of a RAG system. So, and the way they did the evaluation, or I mean the outstanding part of this survey is like they're not only a survey, but they also have experiments and evaluation. And they do such evaluation by prompting language models under prompts like this. For example, when they're evaluating the aspect of transparency, they have a prompt of question and reference, and they say, please carefully think about something and, to reflect some intermediate answer step for the provide a reference. And I haven't gone through the survey in detail, but I think they have some ground truth answering step, intermediate steps that they can measure by the overlap among them. So yeah, here's their evaluation setup. And you're welcome to check in this archive preprint about the full details about this paper. And finally is their evaluation result. So we can see that here's a radar figure for the 6 aspects that they believe is important for the credibility of the source in the RAG system. So yeah, we see that models, older models like Llama 2 13B, which is still very relevant in 2024, but not very relevant today. We see that it's not performing very well. We see this green, small, very green shape here because it's not performing very well in all aspects. So its area is very small. So which is the best one? I would say the yellow one here. Oh, sorry, it's not very well. So we can see the yellow one is GPT 3.5. It is very well on transparency, fairness, robustness, factuality, and accountability. But the aspect of privacy is dragging down its overall area. I think according to the definition, privacy means that we shouldn't use private data from any source to be used as the RAG. So it means that GPT 3.5 Turbo is not doing a very good job in this aspect. So which one is the best? I would say probably the green blue one. The sapphire one is the best. GPT-4 is the best when the authors compiled a survey in 2024. Yeah, okay. That's me for my presentation. Are there any questions for this survey or the intro?
Any questions for Yisong? Okay, maybe we go ahead for the next segment, given the time constraints that we have.
Okay, thank you.
Thanks, Yisong. So, who's on the next? Yeah, okay. Nayan, right?
Yeah.
Okay. Can you share screen? And can manage to use the pen, you're welcome to use it.
I would-
You need to share the entire screen, maybe it's better.
oh. Hello everyone, I'm Niall, and today I'll be talking about provenance and authenticity. So basically, this is quite important because we need verification if the source is real or not. And in today's world, where almost everything, all content we have is doubt: is it real? Is it fake? And it's very hard to tell with even AI generated content. I believe this is a very important area to for us to know about. And the title says beyond text because traditional text-based verification methods are now outdated. They just don't work for existing multimodal content. And we need something that's fundamentally different and robust. So the trust crisis, right? The first issue is, or the first challenge is basically synthetic media is now ubiquitous, and it because of the very fine line between real and fake, it's increasingly convincing for us to think that what is fake could be real, and we need to find ways to tackle this issue. The second main challenge is the traditional verification methods have failed. The methods used so far were to look for image or video content was compression artifacts, checking metadata, and analyzing lighting inconsistencies. But modern generative models easily surpass all of these tests, for which we need to be careful because right now we're sort of flying blind on these areas. The third is users
cannot distinguish between manipulative and authentic, evidence. So even when I use ChatGPT, so I work in research, I work in quantum computing research, and it's because it's such a niche field. There are a lot of things that I don't know on a daily basis, and when I ask ChatGPT to explain from scratch, like explain to me like I'm 5, of course it does have those citations that it provides. But later, when I click on those links, I realize the explanation is not very fitting to the things that they've provided, which makes it very easy for me also to believe that, not every one of us click on all links, right? But when you click on them, you realize, oh, there's a huge inconsistency with what claims and what the links are saying. So the stakes are quite high, with misinformation spreading faster than corrections. According to statistics, misinformation is 6 times faster than a correction. So if there's already some information out there that's not real, it takes 6 times the effort for a correction to reach the same audience, but you're never really closing the gap. The second is the erosion of trust in digital evidence, be it journalism or courtroom cases. And then there are some critical decisions that rely on unverifiable content, because in future, if we're using AI into like judicial systems or medical systems, we do not want false data to be the evidence for some decision that the AI system or the human is going to make. So what's the solution? The solution is basically content credentials, which means being able to capture and edit chains with possibly cryptographic signatures. There might be other ways to do it, but I'm just highlighting one because on the interest of time. So what are cryptographic signatures? They think of it like a blockchain for content. So every time something happens to a piece of media, from the moment it is captured to every edit that is made along the existence of that particular media, the action gets logged and cryptographically signed. So there's a record of every change that's been made. What exactly does this capture? The device or the tool that's been used to create the content, the exact timestamp of creation, every operation, for example, cropping, filtering, AI enhancements, everything. So every edit operation is tracked, and most importantly, whether AI was involved in the creation of content. Why does this work? Because it's tamper-proof or tamper-evident. If someone tries to modify the content without updating the credential, then the signature breaks and you immediately know that something's wrong. There's like an attacker. It provides chain of custody proof, which means, can correlate it to like evidence in criminal investigation. You can trace the entire history of that content. And crucially, this isn't just theoretical, it's actually being followed, and the standard is called C2PA, which is the Coalition for Content Provenance and Authenticity. And this has been used in real time by big names like Adobe, Microsoft, Canon, etc. So also what's interesting is these credentials are both human readable as well as machine readable, which means they can be used for transparency in automated systems. So I'll be talking about attribution evaluation because we need technical infrastructure, right? So even with perfect provenance metadata, there is still a fundamental problem, which is evaluating whether claims are actually supported by evidence, and this is sort of hard. So a recent paper from called Attribute Bench, which was published in ACL 2024, basically tests this aspects systematically. So they took state-of-the-art models, including GPT 3.5, and fine-tuned specifically for this particular task that they were doing, which is to classify. They did a binary classification of whether a certain information is attributable or non-attributable. And the result was only 80%, there was only an 80% score of macro F1, which means 1 in 5 evaluations is wrong, and we do not want that kind of error bar. So they did something really interesting, which is they analyzed about 300 samples, which are 300 error case samples, and to understand why the model fails in the case that it did. So 66% of the errors came from what they called fine-grained information insensitivity, which means which contain basically three areas, which is missing nuanced details and not being able to infer or summarize where it came from and overlook like subtle contradictions. What we also need to note is these are errors that are very easily made by humans as well. And the other 27% of the errors was from information access mismatch, which basically is so human annotators can see the full web page or the full document, whereas for a model, it sees only extracted snippets. So the information given to a human versus the model is self-different, which also makes the judgments different from the judgments made by the human and the model. This is basically how attribution bench works. As you can see, this was fed into GPT 3.5, and the claim was the population of Thailand is about 60 million. And however, the reference discusses certain connections with like religion and stuff. But so what GPT 3.5 passed the judgment to be was this information is non-attributable, but the ground truth is it is attributable, and the same in another case as well. So how is this different, right? Like we always use F1 score, but what did these people do differently? Like the authors of this paper, they introduced something known as macro F1, which is basically taking unweighted average of the F1 score, the precision and the recall. So they calculated the F1 score for attributable classes and the F1 score for non-attributable classes and took the unweighted average of that, which is different from the usual F1 score that we talk about. Why it matters is because so we need a balanced data set. And it's because when you're training a model, we need to know that it's not giving preference of one kind of data or one area, or basically if it's a binary classification, should not be giving attributable more weight than non-attributable. So having this balanced evaluation is very important. And it also achieved okay, yeah. So it detects when the claims are supported by evidence and when it is not. So when they are supported by evidence, it labels them as attributable and non-attributable at the other times. Some of the key takeaways from this is so the benchmarking was very important. The way they did the whole thing and the way they studied the 300 samples and the insights that they got from that was very important. So just as Provenance needs verifiable chains, evaluating attribution needs very careful setup as well. And design choices also matter because if you don't have like a balanced class, then you're going to see a lot of anomalies. And what they did was they basically took 7 data sets, 4 for the ID and 3 for the OD. So basically, ID is the indistinguishable or something like that, and out of I think I don't remember what word, but like
Probably distribution.
Yeah, distribution. Yes, it was in distribution, which means it's trained on those 4 data sets. And out of distribution was basically trained on 3 data sets that is not given at all in the testing. So in the training, so they are tested on a different data set altogether. So it basically does not just take a look at semantics or linguistics, but actually looks if there are patterns it's able to catch. And also for generalization purposes, they chose to not have the training data set and test data set to be different. This is so there's something known as the AIS framework, which brings us to okay. So this is the paper from Google DeepMind, and is published in Computational Linguistics, which is a very renowned journal. And it asks a simple question, which is, can generated text be verified against the sources that it provides? And it's a 2-step process. So step 1 is the interpretability, which means, is the text understandable on its own? As in, are there any grammatical errors? Does it sound weird when you just read it normally? Those are the things that's a very basic facts that it looks at, like that how ambiguous are the references and such things. So the second step is the attribution test. So basically, can I quote something? Can I say that according to this source and make a claim? If I can't, then the source is not attributed. The key innovation here is something known as explicatures, which is a formal model for meaning and context. So basically, it just handles tricky cases where context is important. And a simple example of what an explicator would be is if I'm asking a model, when was the iPhone 17 released? And then the system says it was released on 19 September 2025. Basically, the it that it's referring to, it's able to contextualize from my question itself. That's an example of what explication means. It already has an idea of what it's talking about. And this has been done, so it's validated across tasks like conversational, QA, summarization, table text, etc. Missing and forged credentials. So in a real world, credentials are often missing or forged. And in terms of missing credentials, there are 4 things. So assume untrusted by default, which means no chain means no verification. So you don't have something tagged to it means cannot verify. The second is flagging it explicitly in the UI so that users know what they're looking at and how believable it is or how true it is. The third is lower the trust scores in your ranking and retrieval system. It should not be shown at a higher level when people look for something that it quotes for. And then the fourth is it's important to have clear warnings, which means transparency is key. Coming to the forged or manipulated credential cases, this is the adversarial case where attackers will try and fake credentials. So how do you defend, right? So cryptographic verification, basically check the signatures. If simple math doesn't work, then reject it. That means it's not attributable. And certificate revocation, like SSL certificates, you need a way to be able to block compromised signing keys. Next is anomaly detection. So you need to flag suspicious editing patterns. For example, if you have some sort of media, and then if the media is edited 47 times in 3 seconds, then you know that's humanly not possible. So you flag that as well. Then trust anchors. So basically verify against known authorities, legitimate device manufacturers, etc. And the best practice is basically create credentials as evidence, not truth, and always combine with other things. So attribution is not equal to authenticity. We should try and get this as clear as we can because it's the foundation of everything else that follows here on. So attribution confirms that what the model says aligns with the source, and it is a linguistic check basically. So does this claim match the document that it is quoting, or basically the AIS that we discussed previously. And authenticity, what it does is it confirms that the source itself and its entire chain is trustworthy. So this is the technical check. The attribution is the linguistic check. And the gap here is basically missing or forged provenance breaks the attribution link. So you might have a perfect linguistic alignment with the source, but if the source itself is fabricated, then the attribution is meaningless. Which is why we need a unified framework where we have attribution, provenance, and credibility together, and the overlap is what the trusted AI evidence is. That's where you want your AI. So naturally, we come across the question of how do we build this, right? So bridging the bridge to RAG, so credibility signals. First is metadata enrichment, so you add provenance to the embeddings, track credential status, and second, retrieval re-ranking. I think we'll talk about in previous classes as well. So boost verified content, penalize missing credentials, just simple math. Third is generation grounding. You weight by provenance and trust the metadata in context because that is already verified. The fourth is citation and transparency. So just be as transparent as possible. Your user should not user should not be confused. Yeah. This is the provenance aware RAG architecture. So it starts with the ingestion and then goes on to the verification and scoring. And on the indexing side, just indexing, retrieval, and the generation. So like it's quite, I think it just explains. So the key signals are credential present, signature valid, edit chain intact, source reputation, and need check for missing data and ethics. The key takeaway is provenance is the substrate for trust. So content credentials provide cryptographic, as I mentioned. Attribution evaluation remains hard. So even SOTA models struggle with nuanced verification. They can make mistakes. And third is treat missing or forged content explicitly, like no credentials, downgrade or give them a penalty, and make trust transparent. The next session is by Nikhil, which will talk about credibility aware RAG.
Okay, let's thank Naran.
Niall.
So let's just spend a minute or two thinking about what Niall has presented. So we have any questions from the audience? There were 2 discussion catalysts that are posted in Slack. So if you have Slack in front of you, you can look at that. Hightower and myself have already answered some of the questions there. So, I mean, credibility has been a problem in search engines from day one. And one of the other problems that we see is that we want to make certain sources trustable and findable and accessible, right? So, for example, when we do RAG, you might want to trace back to an open source like Wikipedia or some type of repository that gives authenticity, as Diane also pointed out, right? But these resources, they are also encumbered. Operating a website and being able to make it freely accessible by all is a cost. Okay, so for example, Archive, where we read a lot of papers from, services billions of requests, right? Millions every day. It's not cheap to send all those electrons all around. So that's why if you go to Wikipedia or Archive, they're always asking for money. And with RAG, actually, we're compounding that problem, right? Because every time we're asking GPT or AI mode or whatever to come up with a summary, they have to go access all of those websites, right? They have to pull that information. They summarize it, they present it to you, and what do we ask you to do? Oh, go back to those same websites and do it all over again. Of course, that's necessary, but you can see where this is compounding problems, right? Because we need to check on the provenance of this work. And unlike a search engine, which is not accessing those websites, they've just done it once, they've indexed it, and they're not pulling it at runtime, right? But when you make a query to a RAG system, it is indeed most often either pulling a cached, very recent version, or actually live going to that website. In fact, if you talk to many of the providers of Wikidata, okay, which I went to a meeting behind last month or 2 months ago about that, they're very concerned. RAG traffic is a huge amount of cost. The electricity involved in serving RAG users is 10 times the normal request. Okay, and you can see if everyone's going to use ChatGPT, their cost and balloons, right? And you can see if we can't service and be able to make these resources apparent, fact checking and credibility aware systems will be even more of a problem because you can't get to Archive, you can't get to Wikipedia to check. And how you know that it's right? Okay. Any comments from anyone? Yes,
I'm very interested to hear about that something they use the blockchain for this. Is that the way it's in practice or is it just solved?
Maybe Niall can also address that. Is blockchain the solution set?
I mean, it's just a cryptographic protocol. I just sort of try to give an analogy with the blockchain because to think about it like that. So
Again, but the setup that's
it doesn't exist. It's just
that's my question.
yeah.
Thank you.
So yeah, blockchain is definitely a very useful technology. Requires at least 50% of the distribution network to be distributed, right? So that's also a difficult issue because you need enough players for a blockchain to be robust, right? And getting that support from worldwide is not that easy either.
Not enough motivation.
Yeah, I mean, it's to provide a good for the commons, right? It's sort of like water and air. I mean, if you have to pay for those resources, it's not so easy to get, right? And if one person doesn't do it, or uses it poorly, it suffers for everyone.
And there's also the environment issue.
Can you elaborate more on that?
Yeah, because using blockchain or such technologies just increases the amount of energy that you use, even for like tokenizing one aspect of the thing. So when you do it like billions of times, then the amount of energy is exponentially high. So again, it comes back to already LLMs using a lot of energy, and then do you want to inject something else that's going to increase that?
Right. This is a very good discussion because you can see the technology that we are creating creates more use of energy, right? And so unless we have a pairing on the other side to make more energy efficient use of our resources, we're always ramping up our computational requirements. So, those of us 10 years ago, you couldn't imagine the amount of energy being consumed to do certain basic things that we take as for granted now, right? Okay, Nikhil, are you online?
Yeah.
Okay, we're on our screen share and let you take over.
Yeah, I'll share my screen. Just a minute. Sorry.
And you can share, and when you're ready, you can start.
Is my screen visible now?
Yes.
Okay.
Jump into presentation mode and it's all yours.
Yeah, okay. So hello everyone. So now I'm going to present the section 3 of the presentation. So like from section 2, we can understand that we can now verify the document authenticity and track content origins. However, there is a big challenge there. The challenge is that not all retrieved documents are equal. By equal, I mean that not all documents can be accurate. This means that the RAG breaks when the context is flawed. By flawed, it means that it retrieves irrelevant, outdated, or misleading text. The generators may use low credibility snippets if they look on topic. The simple filters that we put can drop useful evidence, like how it works that mixed quality documents go into the system, into the retriever. The how an RAG pipeline works. The mixed document goes there, then it searches for the relevant chunks, then it orders by the evidence quality, and then it generates the grounded answer. So with the low quality documents, there is a very big impact that the performance of the LLMs drop by 20 to 30% because of this misinformation. And as we can see that one low quality document among many good ones can mislead the RAG. So the thing is that we have to treat the sources and spans by credibility and not only by relevance. So the credibility problem in RAG. So what is the meaning of high credibility, medium credibility? So the thing is that for example, a high credibility document can be a recent news report on the event or a peer-reviewed high impact literature. A medium credibility document can be like a general reference page from an encyclopedia, which is like more of generic, but still it can be still credible. However, if we put a outdated report, for example, a report from 2018-19, which is like 6-7 years old, this can be a low credibility. Something was different that time. Now it has changed. And obviously the is AI generated misinformation is always a low credibility. So the big problem is that standard RAG treats all four equally, all these type of 4 documents equally, leading to confused and wrong answer. So what's the good solution of this? The best solution is credibility aware RAG. So weight the documents by credibility, which will help to get the correct answer, and explicitly tag each document with credibility level. Okay, so the credibility aware RAG, it basically means to place trust inside the pipeline. So a standard RAG works on this formula, works on this function, that LLM function which has a query and documents. And a credibility aware RAG will take query and will also consider credibility and document alongside the query. And the each document will be tagged with credibility. So the credibility dimensions, what are dimensions of credibility? The relevance, does it answer the query? The timelessness, is it current? And the source, obviously, whether it's a high impact peer reviewed literature or just a low impact literature or anything like that. So the key insight, don't hope the model figures it out. We have to tell it explicitly that which is high, which is low. So there are three paradigms, like there are three different paths to the same goal. There are three different types of methods. One is RAG, where it acts. It acts like for retrieval and aggregation, and there is no training required for it. Second is CAG, which is in the generation training phase, and however we need to train it. And the cram, the generation, which happens in the interface phase, and it also doesn't require training. So just giving a very brief, like a real world explanation of all three before I go to technical, I would like to explain what is RAG. So you can think RAG like as a bouncer in a outsider like a club or something, who's checking sources at the door and weighs the trustworthy once more, that they follow all the eligibility criteria, that they are above 21, they have a legal age and everything. So you can assume like that. The CAG is like a student, like teaching a student to recognize which is a reliable source and which is an unreliable source. So as we are teaching it, so we have to train it. And the CRAM can be considered as a glasses, like we can adjust the glasses to blur out the distractions and focus on what's clear. So all the three integrate credibility in different ways to achieve trustworthy generation. And they all deliver double-digit gains over standard RAG in noisy conditions. So explaining each of them technically. So reliability, aware retrieval, augmented generation. So technically speaking, it estimates per source reliability from cross-source agreement and uses it to filter, re-rank, and aggregate evidence via weighted voting. So if I break down its steps, so the step one would be to estimate source reliability, offline one. So cross-check 200 fast-checking queries across sources, which sources agree with consensus, and there is no manual fact-checking needed. And at the query time, retrieve per source. Get the top K documents from each source separately. It can be top 5, top 10, depending upon the data and what we are doing with it. And then select K reliable and relevant sources. Only consult the top K sources that have relevant info. If K is equals to 4, like if we take the top 4 of the 1,000 sources, so it means there is a 99% token reduction, more than that actually. So, and then aggregate with weighted majority. So the answer would be argmax multiplied by sum of reliability into vote. So just giving a simple example as was given in this Huang et al. Paper of 2024. So fast checking query was what causes the COVID-19. So the sources were source A, the CNN model says the SARS-CoV-2 virus. Source B, the conspiracy blog, which said 5G networks. Source C, Mayo Clinic, which said SARS-CoV-2 virus, and Wikipedia also said CoV-2 virus. So reliability estimation. So sources agreeing weighted to high reliability. Like we can see that three of the sources, CNN, Mayo Clinic, and Wikipedia said that we would go with the SARS-CoV-2 virus. So hence we can see that as it was like this was the highest one. So reliability at query time to current. So it will go with this ones like the SARS-CoV-2 19. So at query time, query current and employment rate, weighted voltage. So this is just was another example in the paper, but this is the main example that why it would give SARS-2 because majority of people have said that. So now going with the second one, the credibility aware generation. So technically speaking, it means to fine tune the large language models on data where documents are labeled with credibility plus model to generate the reasoning. So it has a two-step data criterion, like creation, sorry. So the multi-granularity credibility annotation. So it means to use retriever to score relevance, classify into high, medium, and low credibility, and apply it at document and sentence level. And second is credibility guided explanation generation, to prompt GPT 3.5 to generate explanations that analyze credibility, as it was done in this paper, this Pan et al. Paper. And the example was the high credibility Reuters article states X, low credibility blog says Y, considering credibility answer is X. So the answer should come like this. So just giving more about the example, the CAG training data example. So input to model. Who won the first Nobel Prize in physics? A high credibility, as we taught it, would be that William Roentgen won the first Nobel Prize in physics in 1901. So Nobel, which came from this Nobel Prize app, official website, which we have given the input. And the low credibility document can be the Albert Einstein won the first Nobel Prize in physics, which is like some person who has blogged, just put a blog. So what would be the output from the trained model? The high credibility document from the Nobel Prize official website clearly states that William Roentgen won in 1901. This is authoritative as it's the official record. The low credibility document claims Einstein, but this contradicts the official source. Einstein did win a Nobel Prize, but not the first one. So the answer would be like this. So the CAG model would give you an output in this format, as we can see. Okay, so the third and the last one, the credibility aware attention modification. So it adjusts the attention at interface by downweighing the tokens from low credibility spans using calibrated hard scaling. As we can see the architecture in this figure, which is given by Deng et al. So it's again a two-phase process. Phase one, to identify the gullible heads. Use the 100 calibration example with misinformation. Extended casual tracing, which heads are most affected. Select the top 100 to 300 influential heads. Phase 2, modify attention at the interface. For the low credibility documents, scale down attention. For the high credibility documents, keep attention normal. Just like what I said to make the glasses blur for the distractions. So don't be attentive to the low credibility documents. It is trained like that. Only modify the influential heads identified in phase 1. So and hence we are not putting the details to it. We are not teaching it. So there is no training required. It's a plug and play method. So how crime works? Attention modification example. So query, who won the Nobel Prize in physics? Documents, credibility, a 0.8 credibility document says William Roentgen won in 1901. A 0.1 credibility says, like it says, Albert Einstein won in the Nobel Prize. However, the standard RAG rating, William 30% attention each and Albert Einstein get 20% attention each. So Cram's model attention would be based on this formula, and then it does the renormalization. And from the renormalization, we can see that it adds the documents and model focus 92% attention on the credible document. This is how it works. Okay, so which method to choose? How we will come to know that? So first of all, we come to know that there is a need of credibility aware RAG because we are not sure if the document is credible or not. So first thing we need to check that do we have identifiable sources like the CNN, BBC, Twitter accounts. If yes, then the best thing to use is RAG because it has the best explainability and it scales efficiently. If we don't have the identifiable sources, then we have to check, do we have training sources? Like, do we have example? Can we train the model? If yes, then use the CAG because it's one of the best overall, as we'll come to know later, and it generalizes pretty well. However, if we don't have a training sources, then we have to go for this CRAM model. The good thing is that it will give you immediate outcomes. And so no training required, as we discussed before, so it doesn't require any training also. However, it won't be the most accurate. We can see the paper. So the performance comparison from all three methods from the papers that I put before, the RAG multi-source excellence, we can see for the natural quotients, it had the accuracy of 73.7% versus the 63.4% of the standard RAG. The trivia question answer, it had the accuracy of like 91.3%. And compared to standard RAG, which only had 81.2%. The real world validation RA correlation on political fast checking. It had a correlation of this 0.99 on fast checking, and they had given a full example on that. The scalability, it has a 99% token reduction with KRASS. So however, and if I talk about the second one, we can see it for the hotpot question CAG, for the hotpot QA, it had like a 50.9% accuracy, which was increment of like 82% accuracy for the base model, the RAG model. The second one, for time sensitive QA, it has like more than 91% accuracy, like 91% more accuracy than the standard baseline RAG model. For the misinformation, it rather increased by like 147. Still, it was 44.2%, but the increase was pretty good. And the noise robustness, it had 89% accuracy at 80% noise versus ChatGPT, which only had like 77.3%. So the third one, CRAM, which didn't have any training, it was not really much trained and didn't have much explainability and was very quick. So its accuracy was also really not very good for national questions compared to what we have for RARET. So it was like 33.6%. And for the trivia QA, it is like 59.9% questions. It beats the CAG. It still beats CAG by like by a margin. But however, for the adversarial, it had accuracy of 91.3% for 1 to 72.2%, which was equivalent to the Oracle performance. And so the summary comparison finally. So RARET required, we have discussed all these things before, that RARET doesn't require training. It needs source IDs. Its performance is very high. We can see that its explainability is again very high. The setup speed is medium. So CAG, it requires training. It doesn't require source ID. Its performance is again high. Explainability is high, but the setup speed, because we are training it, then testing it, then its speed reduces like a lot. And the CRAM model, which doesn't require training, doesn't require source ID, doesn't have a very good performance. It's a moderate to high performance, has a low explainability, but it's very quick. So the limitation and open challenges. So all methods depend on the credibility assessment accuracy. This is a limitation, that garbage in and garbage out. If credibility labels are wrong, what if the credibility labels are wrong? All methods will fail. So each method again has some specific limitation. For example, this RAREG, the source reliability can drift over time. Periodic re-estimation is needed. CAG, performance depends on label quality and explanation coverage. The CRAM, the attention head selection is task specific and recalibration is needed for new domains, because we are not really training it. So every time we have to change it. So the biggest fundamental problem, how do we accurately assess credibility in first place? Misinformation involves constantly. Sources change quality over time. Context-dependent credibility. But even with perfect credibility, what if all credible sources share the same blind spots? For that, we'll come to know in the next section, in the pluralism and bias aware source selection. So thank you.
Okay, any comments? So one thing, I'll just be very quick, because I know we have a lot of sections, but the time dynamic, we haven't talked about a lot, but it definitely interacts with credibility, right? Things that are factual and we know are time persistent and somewhat static, we can do more credibility aware verification. So this goes back to our, again, the very overview of the lecture that Hypop presented in week 2, say that when we know things are temporally sensitive, maybe we cannot assume that credibility is that strong a requirement. Okay, so Zihang is already online. So Zihang, when you're ready, you can share part 4. After part 4, we'll take a short break. I know it's after 7 already. Zihang, when you're ready.
Yeah, can you hear me?
Yes, we can hear you fine. Thank you.
Yeah, and see the screen?
Yes.
Okay. Just apology in advance because I have got a cough today, so maybe there are some interaction during the presentation. So in this section, we will talk about pluralism and bias-aware source selection. And here is the overview of this section. We will focus on 3 parts. First, why credible rankings can still lack diversity or fairness. Then what kind of ranking behavior we actually want. And after that, how this can be implemented as a simple plugin module in the pipeline and end up with some takeaways. And let's start with a very simple iteration for why credible is not the same as diverse or fair. On the left side picture, I asked GPT-5 a factual question. In which year was Michael Jordan born? It does the right thing in terms of credibility. It cites Britannical wiki and maybe some major news. All of these are high credibility sources, which means we have filtered out low quality stuff. But on the right side picture, we can see the wiki disambiguation page for Michael Jordan. There isn't just one credible Michael Jordan. There is a basketball legend, but also a footballer, actor, researcher, and so on. All of them backed by factual sources. So even if we are inside the credible pool, exposure can still be skewed. Almost all the rankings and all the citations goes to the basketball Michael Jordan and to the tiny set of the dominant sites. And on this slide, we will see their differences in mathematical form. First, given the assumption that for every document D, we already have a credibility or relevance score called UD. And classical ranking then just says pick a permutation pi then maximizing the utility, where VK is position bias or user attention at rank K. If we sort documents by UD, we maximize the function UPi. So this gives us a credible ranking, but it says nothing about diversity or fairness. And so far, there have been many studies on search result diversity, and you can click the link below to see this review. And here we use intra-list average distance as an example. It only looks at the distance, pairwise distance between items in the list to measure diversity. You can see the formula. And the most traditional and widely adopted way for defining the pairwise distance is use the cosine similarity. But neither of these two formulas involves credibility score UD. Then fair exposure is also separate. We model the ranking as a probability matrix P, and exposure of a document is the sum over position K from 1 to K of PDK multiplied by VK. So if we get the ranking by maximizing UPi alone, it may still produce very large unfair gaps in exposure between groups. And now let's talk about what kind of behavior we actually want from the ranking. First, think about the pluralism at the list level. Here we reuse ILAD as our pluralism signal. It basically the average distance between all pairs of items in the list. So higher ILAD means items are less similar to each other. But pluralism is not only about pairwise distance. It is also about coverage over viewpoints or subtopics. Imagine that there is a global set of stances or subtopics called S, and each document covers a subset SD. Then we define the coverage of list L as how many different stances from S are covered by the document in L, divided by the total number of stances. Then a higher value simply means more stances or sources are represented. And finally, at the bottom combined objective, when we pick top K list L, we don't only maximize the sum of UD. We also add these two terms with weights lambda1 and lambda2, which will trade off purely credible versus more pluralistic rankings. So after addressing the issue of diversity, and let's switch to the fair exposure. which is about who actually gets seen in the ranking. First, incorporate probability into UP instead of the fixed ranking. UP can be written in the matrix form, V transpose times P times U. And we also require P to be doubly stochastic. Every row and every column sums to 1. So it really behaves like a soft version of a ranking. Then these forms allow us to link it to the exposure of the signal document of a single document here. And then for a group G, we just average over its members to get the exposure G and UG. With those quantities, we can write down fairness constraints. One example in the paper is called demographic parity. Make the exposure of group 1 equal to the exposure of group 2. And another is a disparate treatment, which says the ratio of exposures between groups should match the ratio of their utilities. In other words, exposure should be proportional to how useful or credible the group is. So in summary, this framework let us control how exposure is distributed across groups while keeping the same scores. And next, let's move on to the how and show how this graph-based adaptive re-ranking works as a plugin. We start for a very standard two-stage retrieval pipeline. Stage 1 is a fast retriever that gives us a large candidate set I. And stage 2 is a slower re-ranker that scores a smaller set and produces the final ranking. And in our cases, we can treat credibility filtering as stage 1.5. So by the time we enter this box, all documents are already in the credible pool. And in the box, the extra structure is a corpus graph, CG built offline. In graph, each node is a document, and for each document, we store its k most similar neighbors. And online, we run the JR loops with a frontier F. The step 1 is to take a batch of documents from the initial set I, score them with the re-ranker S, and append them to the final ranking R. And step 2 is for every score document, we look at its neighbors in the corpus graph and push them into the frontier, and with some initial pre-score. And step 3, take a batch from the frontier, we score them and with the same re-ranker S, then append them to the R, and again push their neighbors back to the back into the frontier. These loops will repeat until the scoring budget is hit. Then this slide will show how the policies actually steer the graph and the frontier. First, every document is tagged with some group label like source, region, stance. Then the first set are pre-retrieval policies, which control how we build the neighbor set, which is a Z. Policy 1 is diverse group linking, keeps only neighbors from other groups. So each node's neighbors already points across groups. And policy 2 is balanced neighbors quota. So each group can appear equally often in the Z. The second set are in-process policies, which control how we pick documents from the frontier or the initial set. The policy 3 is frontier filter. When we add neighbors into the frontier, we jump safe group neighbors, so the frontier also remains cross-group. Then the policy 4 tries to keep equal group proportions whenever we build the candidate pool or a batch. Then policy 5 is group-wise top scoring. So every group gets a fair share of the batch. And the policy 6 is within each group, preferred neighbors discovered earlier in the loop, then by the score, because those are more likely to be relevant. And finally, when these policies, especially 5 and 6, we can choose their per group top dogs. We can control pluralism by adding a diversity score, like delta diversity. So at the selection time, we are respecting group balance, keep credibility, and pushing the list towards being more diverse at the same time. So here are some quick takeaways, and that's all from me today. Thank you.
Okay, we'll take a 3-minute break, and then we'll go on to our next segment. So if you need the bathroom or anything, come back at 7:20. What? Okay. Jiecheng is, are you online? Jiecheng, I think is on the next segment. I didn't see.
I wonder, like, how can we give the PDF to the text?
You can mail it to them. I think there are instructions on the information that presenters were given, but I'll double check that. Yeah.
It looks like if we were to go there and tell them our name,
Yeah, they will ask you to go to, I think, support at CLMP. Just double check this.
Is it the assist?
I think you can actually go here and then ask them for others, then put the subject line, then you attach your file, but I'm gonna double check. That's how they want it. So I think if you got the instructions from our steps coordinators, they should have attached some PDF file giving you instructions for how to do the poster printing, but I'll just double check.
So far I haven't received that, I'm sure it's because not necessary.
Okay, yeah, no, you don't have to be SOC staff, you just need to be registered as a poster presenter instead. Yeah. So Jiecheng, maybe you're ready? Yeah, you can come up and present. I will go find out the answer to Jiaying's questions about posters. The button all the way on the right. All the way on the right.
Hi, hello everyone, I'm Jiecheng, and today I will talk about the factuality and also the attribution measurement. So I will first begin with the problem of the backfield citation problem. So what is the backfield citation? It is a method of attribution which is to citing some sources, but these citations are added after the generation process is complete. Maybe you can imagine these situations where large language models they are answering some questions about a famous person, and he first directly generated all the biography of these persons, and then it just began to search for the internet and randomly add some relevant or irrelevant citations to all of the answers that he has generated. So this is different from the attribution during the generation, which is also a method of attribution that the large language models just first generate every sentence and then get the attribution and verify it. And this is so the difference between these two citations is that the first one is requires very low resources and also it is very fast. But the second one is very costly. So maybe some large language models don't want to cost much and they just first generate an answer based on their internal knowledge and then added some relevant or irrelevant citations. So the drawbacks of the backfield citations is that first, the models did not use the sources, which may cause some errors in the factuality. And also the second is the misattributions of the truth. Maybe there are some cases when, although the large language model generates the right answers or the facts, but their citations is irrelevant or the citations not verify what they answered. So think of these backfield citations, and we will try to figure out it, and also we will try to avoid these problems. So in these situations, the factuality is very important here, because if the factual accuracy can't be certified in the large language models generation, do we really need to care about the citations or the attributions? Actually, I think we don't need to care about it because there is some factual problems in the answers. So if the citations is relevant or the citations can verify the answers, it doesn't matter or it doesn't make any sense. So the next question is if the large models can answer something that does not have many the factual problems. So this time the attribution measurements is important here because we need to verify whether the generated statement is fully supported by the cited reference. Because maybe we need to use these citations for some further studies. So I will first talk about the factualities of the long-form text generation. I have to mention that this factuality doesn't have relations to the attribution measurement. It's just verifying whether the large language models generating generations has factually problems or doesn't have a factually problems. So there are many famous or classic methods on it. And the first, I will talk about the factor score. The factor score is a new evaluations of the factorities of the long form text generation. And look at this picture. It asks the large language model to tell a bio of famous people. And the ChatGPT generates a long form text which contains many facts of these people. And we can see that some of these facts are right and also some of these facts are wrong, according to the Wikipedia. But the formal evaluation of the factuality only gives 0 points to these two answers because it analyzes the answers in a general or in a whole. So the ideas of the fact score this paper is that it breaks the generation into a series of atomic facts and also computes the percentage of the atomic facts supported by a reliable knowledge source. In this paper, it is the Wikipedia. And the good news is that it can distinguish from different answers. For example, in the first situations, it has more factual scores. because it has more correct atomic, it contains more correct atomic effects. So this is the definition of the factor, which is very easy to understand. Now the problem is that how to get the atomic effects from very long text. And the answer in the paper is that they just use large language models to generate the atomic effects, which are based on every sentence. For example, there are many sentences in this generation, and they divide it and also ask the large language model to generate whether these are the atomic effects. And usually, a sentence can be divided into many atomic effects, and these atomic effects add together, and they are evaluated one by one. And also they found that using human evaluation to verify these effects, these atomic effects, is very costly and time consuming. So they propose a method to do the automatic score generation, and it contains many parts and also many methods. There are 4 methods they use here. First is a non-constant large language model, which directly judge whether atomic effect is right or wrong. And second is the retrieval, and also using large language models to generate. It retrieves the top 10 answers, the relevant passages from the Wikipedia, and ask a large language model to generate whether it is right or wrong. And the third is the non-parametric probability. And the detail of this you can see is in the reference paper at the bottom. It can be seen as a pure retrieval method, which it masks every token in the generation, and also it uses retrieval to retrieve some relevant answers, and then it averages the results of every mask token to judge whether the generation is right or wrong. And the third is an example method, which uses the retrieval method, and also combined with the non-parametric probability to give a final answer. And the results are there, which is not very important, I think. And also the paper find that about more than 30 of the supported and also the unsupported sentences have citations respectively. So which means that it seems that the citations most often have no impact on the factuality. So which really refers to what we call the backfield citation problems, because no matter whether you have citations, the correct answer is about is nearly the same. So next paper is also about the factuality and of the long form text generation. It's called the very score. And the key idea here is that he found that in the previous study, like I mentioned, the fact score. So they find that not all claims are verifiable. We can see that from the picture and from the left side of the picture, and the claim 2 and also the claim 6. These answers are dependent on the context, and also some of these claims they don't have they are not verifiable. For example, the claim 6, because they have no information on the Wikipedia entity, and also these things are not what we call the fact. And this paper finds that not all claims are verifiable, and they also find that the facts may depend on the context. So there are many ambiguous references using the prompt. For example, in this picture, and in this sentence, it's large, starchy, sweet tasting tubulous roots. And this sentence have its, but when using the previous method, and it only contains the is, but they don't know what the is refer to. like the method in the facts for. So this atomic factor generation is not very good because it dismisses the context in the generation. So in this method, they also add some prompting to ask the LLM to generate the atomic facts by considering the context beyond this sentence, so that the its can be referred to its real entity, which can generate more better atomic facts. And also in the score calculations, the researchers find that if a large animal generates only a few facts, or they even don't generate any facts, and they will have a very high precision score. So they added a recall score to it, and also which will penalize these situations. And the recall is very easy. The K here means the average facts that a large model generates at the average level, and also the SR means the fact that they are answered correctly. So next I will talk about the atomic attribution environment. So in the second part of our lecture today, actually they have mentioned a benchmark called the attribution bench, which is relevant to what we talk here. It also the topic is that manually verifying whether the generated statement is fully supported by the cited reference is costly and consuming. So they are using the large language models to verify whether the generated statement is fully supported. And different from the previous paper, they propose a new classification framework which contains three labels. And the first is attributable, which means that the reference fully supports the generated answer. And the second is extrapolatory, which means that the reference lacks sufficient information to validate the generated answer. And the third is contradictory, which means that the generated answer contradicts the information presented in the reference. Let's see examples. And the example asks, there are three categories in them. The first is what we want, which is called the attributable, and which means that the large language models answer these questions, and also they give a reference to the answer. And when we open the reference, which is a website, and we found that these facts are the same, and we can attribute our answers to it. And the second is have some problems, because it doesn't answer the reference or the citations doesn't answer the problems. It just offers something that is relevant to the larger language answer. And also the third one is what we call the contradictory, which means that there are some contradictions between the generated answer and also its citations. And this paper just prompts the large language models this paper gives two methods to solve these problems. And the first is that they prompt the large language models with a clear evaluation instruction to judge whether the citation really answers or really answers the question. And also, and the third is that they fine-tune some large language models on a set of diverse proposed data sets. And they test their methods on the atomic attribution measurements, and they found that there are some misspecified examples which are very interesting here. And first, the most common problem is that when I asked the large model to judge whether this citation really verified this answer, and the citation will be very long, so that it contains many nuanced information or the fine-grained informations. and the large language model counter detected so that they got a misclassification. And the second problem is that the large language model misunderstanding the task definitions and also the logical relations implied by the labels. And the third problem is that the large model failing on the symbolic operators. For example, there are some math operations or math calculations and all, and this is the large language model can't recognize this, so that they judge it wrong. These are a complementation to the previous what we call the attribution bench paper, and I shared here. Okay, that's all for my part, and do you have any questions?
Okay, let's thank our speaker. So, okay, let's go directly to Aaron then. Yeah, thanks. I did want to say one small thing about what Jiecheng presented. You'll notice that in a lot of the research that we do at NUS, there is a Center for Trusted Internet and Community. And Jiaying, who is our coordinator for lecture today, is working very heavily on that. And some of what Jiecheng presented was about attributable, extrapolatory, and got the last one. Contradictory. These are very similar to what we do in fact-checking research. So in fact-checking, you want to be able to say that a source verifies a fact, right? Whether there's enough information to conclude it or not. So in certain cases, we have that third category, extrapolatory, which we call in other data sets not enough information, or NEI. Okay, and then there's the refutes category, which says that there's information that contradicts that. So you may see two sets of different terminology that Jiecheng presented, but if you also read fact-checking papers, those three categories are also mapped over. Okay, take it away, Aaron. Thank you so much.
Okay, so are we talking about uncertainty, calibration, and abstention here? So in this paper, it talks about how traditionally black box methods are used, or white box methods are used to determine the confidence of models. So typically you look inside the model internals, inside the probability of the next token actually being generated. However, it states that there are several problems with this. One being that many models are actually closed source, so you can't look at the internals of the model. And also high probability of the next token being generated does not mean like actual confidence. So for example, if a sentence says chocolate milk comes from brown cows, the next word might make sense to come after the other. However, it's not semantically accurate. So this paper looks at black box methods. So it involves several stages. It involves prompting the model to ask for confidence scores, as well as sampling it and using various aggregation strategies to come up with a final confidence score. Yeah, so some of the prompting strategies include just vanilla prompting strategy, which is just asking it what the confidence score is. Other ones we're going to include self-probing, which is inspired by the fact that, like, if you ask a human to evaluate someone else's answer, it generally provides a more accurate evaluation of the answer. So in this case, it involves like asking a question in one chat and then starting a new session and asking the LLM to give a confidence score for this answer. Other prompting strategies include multi-step, which is breaking down the problem into case steps and then getting confidence at each step and then aggregating the confidence into one confidence score. Also includes top K, which asks the model to provide multiple guesses, and it's at least it makes the model aware that there are multiple different answers possible, and it uses this to produce a confidence score. Yeah. So how the evaluation happened was they use so we talk about aggregation strategies. So one of the aggregation strategies would be just consistency. So you have an answer, and then you ask it again and again, and then see how many of the answers are actually the same as the given answer. Also uses average confidence, which is similar to consistency, but it uses the actual confidence generated for each answer. Yeah, and then pairing basically uses the ranking of the sample answers and then creates a distribution for each answer. Yeah. So yeah, in terms of evaluation, it takes uses two main metrics. One is calibration, which evaluates how well the confidence level aligns with the correctness level. So if a model says that it's 80% confident of its answer, then 80% of the time it should produce the correct answer. And then it also uses failure prediction, which is that higher confidence that's higher or more correct answers should be given higher confidence. So it just differentiates between it's able to differentiate between more giving correct predictions and wrong predictions. Yeah, so some of the findings of the paper include that LLMs tend to be overconfident, and that the different prompting strategies did reduce overconfidence over the vanilla prompting strategy. Yeah, then some other findings include that having more samples does improve failure prediction, and that the pairwise method that they use here had the best calibration, while average confidence had the best failure prediction. Probably because average confidence takes into account the weights of uses weighted confidence to determine the confidence of the answer. Yeah. And then I'll talk about another paper which talks about long form generation. So in the previous paper that we talked about, many of the equations actually use like y equals to y I, right? And that's like, oh, every answer is either correct or wrong. So, but then if you have a confidence course that says that I'm 80% confident for long form generation, it could either mean that you don't know if it means that if I'm 80% confident that the answer is 100% correct, or I'm 100% confident that the answer is 80% correct. So what you want for long form generation is you want to know if the model is X% confident that the answer is Y% correct. And then basically you have this distribution and you want to check it against the actual correctness distribution. Yeah. So how they elicit confidence is somewhat similar. So they use this method called continuous self-evaluation, which involves just evaluating an answer over and over again and seeing how many times evaluating the same answer over again and just generating a probability distribution for it. And another method they use is pairwise self-consistency, which involves just generating answers again and then comparing how similar it is, and basically producing a confidence score based off of this. Yeah. So these are just the various methods they use to compare similarity, which includes like just maybe evaluating based on claims or named entities. Yeah. Yeah, and then they also use calibration similar to the last paper, and how it's different is just that now instead of having the probability that y equals to 1, you have the probability that y equals to s. Yeah, so that's all there is. Yeah, that's all.
Thanks, Eric. Let's give Well, we discussed in Karen's part a little bit about calibration. So, does everyone understand what calibration means here? Can I invite somebody to give it a shot? What does confidence calibration or things of this sort mean, or error calibration?
It should mean like the model should be well aligned with like its verbalized confidence and its actual accuracy. Like if the model says like I'm 80% confident, then we expect that it is actually correct for this bracket of samples 80%.
Right. Okay, so a good domain that's well calibrated is something like weather forecasts, right? Because when we do weather forecasting, we look over like 100 days where the weather was exactly like this at this hour. We see how accurate the weather forecast is 2 hours later, right? And then based on that percentages, then we can say that 80% of the time it did rain or it didn't rain, right? So those things are based on forecasts and then checking, right? But we know humans, and because humans are not well calibrated, that means large language models, because they're trained on the basis of human data, right? Because when they're asked to give percentages, it's basically a next token prediction task, right? So unless you have trained the model and calibrated the model, those things would not necessarily be well calibrated. So those are big problems. I mean, what type of percentages do you think humans are bad at being calibrated about? Aaron, maybe you can say a bit too.
Sorry, what kind of?
Well, what percentages do you think people are bad at determining? Like, do you think people really don't understand, let's say, 100% correct, 50% correct, 70% correct, 10% correct? What are some values that you think might be off?
I think 100%. Oh, it's like maybe you just forget like the off chance that something is like off. Yeah.
Okay.
One of the
Right. So actually, if you read a lot of the cognitive sciences, people are really bad at interpreting probabilities, right? And we're quite irrational when we do that. Like you'll see people avoid very, very low probability events just because they think it might happen to them. You know, you can think about being struck by lightning, or crashing in an airplane, or things of that sort, right? So low probability events, just like what Aaron said, are very hard. Also, mid probability events, like exactly what it means to be like 30% of the time. Actually, people have a hard time calibrating that. So those types of events, language models by proxy, because they're trained with large language data, are also going to be pretty bad, right? So this calibration step that Aaron was pointing out on the last couple of steps, slides using the map, is actually very important to do. And we see that in many domains where you actually have verifiable outcomes, and you can roll them out, for an example in math reasoning and other things, and you can calibrate the certainty more properly in a Bayesian manner. Okay, so I think our last segment is from Jiaying. So Jiaying, over to you. Thanks, Aaron.
Okay, so this was just a brief discussion on like the system design reporting standards from the design rack systems with credibility and retrieval. So there is no ground truth or consensus for this, as I see, so I'm just speaking on my own points. So like firstly, let's talk about credibility with regard to just the retrieval process without actually touching on significant parameters of the baseline model. So about the scope, let's talk about the retrieval index ranking, see how we fuse the retrieved evidence and the confidence citation. And for the goal is like we want the system to output answers that are defensible and auditable by models. So here I'm trying to frame this from 5 perspectives, like what we are trying to publish and maintain as designers of the system. So it starts with the step card, like how do we retrieve random insights, and then about the index data sheet. So this is about the data that we use in our retrieval system. So what data do we index and how do we maintain such data or update such data? The third part is evidence trace. So when we see an answer as output from the system, do we know what evidence actually supported the answer? And the fourth part is the retrieval re-ranking configuration. How do we make it transparent and credible for the users or say like stakeholders of the system? And the final part is the kind of the KPI or diagnostics of the system. So like let's first talk about like some sort of reg stack card. So this is more like a model card for our credibility on the reg system. So the purpose is to propose an audience-friendly document for the reg layer. So here I think one important thing to do is to document the intended use cases and then the out-of-scope cases, such as when we do some health advice cases as presented by the user, then the model should lean more towards abstain. So for here, like I see there is this paper called Model Cards for Model Reporting at the FACT 2019 conference. So they have this intended use part here on like when we report a model, and I think it should be also used when we report such a reg system. So here for the credibility controls, I'm thinking about like how do we weight the different parts of the reliability. So what are the caps of the diversity? And say like are the data is the data reason? How do we handle problems? And what are the thresholds that models sustain? And then say there are also some non-failure modes of the system, such as whether the authority can become stale after some time, or say like the answers are multiples. And finally, is the version and dependencies of the embedding possible rank versions as part of the reg system's model card. And then the second part is the index data sheet. So this is more like the data source from where like our reg system is retrieving from. So here, like I'm thinking of say what we should record or expose from this data set. It's like what is the composition of the data set, such as the domains, language, institutions, also like what data do we include, what data do we exclude, and then how do we maintain or say how do we maintain the data through say how do we maintain the data through say means of curation such as concordance, retraction handling, and say what window do we set for data freshness. And then the third part is about like more the licensing part, the licensing about policy. You also what is the policy of LLM, especially this era of LLM generated content. The fourth part is some sort of non-gets or biases. So here I'm more thinking of like not the social bias type of stuff, but perhaps more like the low resource languages type of stuff. For instance, where the focus might be over reliant on English text rather than text in other languages, so it's more from a cultural diversity perspective. And also the last updated time step. So what is the knowledge cutoff of our data? So then the third part is for the evidence trace. Like, can we make every sentence of the answer traceable to exact evidence and then make it detectable when it's not like actually linked to exact evidence? So here I'm thinking of say for every answer, the system should be able to provide some retrieved document IDs, rings, source, and where's the starting and ending IDs, for instance, like the character of the or the bytes in the evidence. So it's basically an answer set from the long retrieved evidence text. And then like the second part is like I'm more thinking of say some sort of remove every answer check. So this one is solely motivated by the attribution benchwork. So in the attribution benchwork, so they are finding right that in many cases there exists a citation, but like the citations do not actually carry the answer. That means like the citations are more decorative than actually meaningful for the answer. So I've been thinking of say like the remove variance, I'm thinking of say, what if we give the model the evidence in the first pass, then we measure the answer quality, and then we remove each piece of evidence and then recheck the answer quality to show like which part of the evidence is actually say strongly used by the model and which part is more on the decorative perspective. So this one is just purely my opinion. Like it's not something proposed in attribution batch, but I'm just placing attribution batch here as a source of calculation. And then like there should also be some steps for cited sources, such as say publish that, retrieve that, or retract that. And then like there should be user visible citations in response linked to the exact steps. And then this part is more about the retrieval or re-ranking configuration. So this is basically say, how do we document this tunable mix of relevance, credibility, diversity, and recency of all this evidence for version and auditable. So for the embedding and re-rankers, I think it's just quite standard to report all of those model cards or versions for reproducibility and transparency. And then like I'm thinking of say, assume we are designing a model that is like actually well-rounded and credibility is say acting as part of it. Say like we have 4 weights correlated to 4 different aspects: relevance, credibility, diversity, and recency. We should also say like document how we are tuning those weights in our release direct system. The third part I think is quite important is the profile. So what is the preset of our system? Is it like the most condition on safety so that we should set a high weight for credibility? Or say, is it condition on recency, so we must prioritize breaking news? Or say, is it more on pluralism and diversity, that we must prioritize diversity and set a higher weight for that? And then there's also like some fusion or top K techniques, such as when we get lists of evidence or signals, how do we combine them as we select the top of them? And then like finally there's this credibility signal source. So a very brief note whether there's salient reliability prior or similar. For instance, here we can say one example would be the media bias fact check website, where they actually have a bias score for each documented website. So whether it is like what specific biases do their reporting reflect. So I think those, if we are retrieving from them, should also be reported as part of what our credibility is conditioned on.
Can you go back a minute? So here, when you're talking about profiles, are you talking about profiles that a system would expose or profiles that a user would expose when they're using a system? What are profiles attributed to?
Yeah, I'm more thinking of say from the aspect of design, because like assume
A designer of a system?
right. So like assume I am already packaging this system and then like you use it. So it would be good to inform the user like how are we setting different weights for diverse aspects. But I think it can also be done from the user's perspective. So it's conditional whether the user has access to team.
Right, yeah.
Well, you're saying like should be on user's intention whether it should be set first.
Yeah, I mean, all of these dimensions are possible as a provider. Let's say, for example, OpenAI, they can say, I have 3 personas, safety, breaking news, or breadth first. You can select them, or you could condition on the query, right? So you could say, oh, I think this one is a static query, just like what we've heard before about things that might be temporally sensitive, right? So if they're temporally sensitive, maybe you would choose the break news first profile as more likely to be the right profile for this type of query. I mean, it could be a combination, just like you can ask the user what their preference is. Like I've given you breaking news first based on your type of query, but if you want me to re-rank or regenerate my response to make sure that verified things are first, I can do that for you. Right, so many language models now prompt you, okay, what's the follow-up action after satisfying response, right?
Yeah, I think it could be like done both aspects for design things user, but anyway, I think the ways that we make AI, if we set static ways, then that should be conveyed to the user. And if we set uniform ways, then the chance of the option to team should be given. And then I'm thinking of say some KPIs or say like how do we monitor our credibility in other rank systems. So here I'm providing some examples. For instance, like facts, like using facts for like what percent of atomic claim in the answer is factually supported by the actually cited spans from our data. Also, like just some sort of say source diversity. So the degree to which the top pay of this cover distinct source groups and perspectives. Also in the third part, some uncertainty. When we want the model to explain uncertainty, perhaps we wanted more to capture abstention quality, such as like how well the system's not enough information or not enough credible evidence actually match reality summarized by, so this could be summarized by numeric calibration errors, such as some your price fall, and then some sort of risk coverage trade-off at the true abstention threshold. So then like I'm also having some closing discussions, like I designed those in case we had more time, but since we already 3 minutes over time, like let's just keep those questions in mind as a closing discussion. So this summarizes our lecture.
Okay, let's thank Jiaying for our testimony. So maybe what we can do is take this closing discussion and put it on the general channel. And I invite all of you next week, if you are coming to our social, maybe to talk about some of these over a snack or a drink, okay? Because they are very important. I think one of the things that I think about a lot is, you know, the loss of locus of control for people using large language models. Because every time we delegate to a large language model, that is something we're not doing ourselves, right? So it's likely that people who are overly reliant will become commoditized, right? They're not useful anymore. So what we want to do as a society is bring people along with the ride rather than just make large language models more competent, right? We really actually want large language models to be getting better, but we actually want our population to be getting better too. So a lot of it may come to some of the discussion questions that we talked about, right? So is it possible to instill more critical evaluation of information by our own users of LLMs, right? By prompting an LLM to call attention. I mean, Twitter used to be able to say, you know, in order for you to like or reshare a post, you must have at least clicked on the source that you're citing, right? You can't share it without clicking on it. And that turned out to be a terrible intervention for Twitter because they lost a lot of traffic. So they removed it. But you can understand that that type of intervention would actually help provide more factuality and more checking and would inspire more skepticism before spreading potentially fake news. Right? So I'd like you to think about that as something, as everyone in this room is pretty much a designer of AI for the next 15, 20 years. These are problems that are really worth solving, you know, and we are only touching upon tiny bits of it in this class. Okay, so let's thank Jiaying and all of our presenters again. Okay, and we'll see you next week. I just want to quickly note an answer to Jiaying's question earlier. So if you go to our threads and you go to projects, you will see here information about how to print a poster. So this is in the projects channel. So it tells you actually when you can print a poster. So I printed this out. This is actually from the FAQ site within the steps thing. So you go to 27 steps, which is here, and you see there's an FAQ link here, and then you can scroll down, and here it is, information that I have screenshotted for you in Slack. So you have it right there. This is what you need to do. You need to go to rt.comp.nus.edu, select your category, select others, and then say event related A1 coded close to printing for 27 steps, and then attach your PDF file to get it submitted. Okay, so once you submit the file, it's gone. Be printed, all your typos and all. Okay, so then when you have finished printing, you'll get an email. So earlier, I think JF asked whether I need to print it, pick it up right away. No, you can just keep it there. Yeah, during steps, they have like 100 posters there, so it may be a little bit hard, to locate it for you, but they will do it, and then you have your poster on the day of, and then have it. Okay. So that means you may not even actually have to physically go down. You can just do this online in the comfort of your own air conditioned home in your PJs, and then send the.
So we just need to submit this by next Tuesday online, then we can collect it on Wednesday, right?
Yeah, so it says here 7th, 10th, and 11th. So this is Monday and Tuesday, I think, because this must be Friday. Okay. So that's also here. So you can just go through the slides for the exhibitors. That's all you, and another thing that tells you about costs. Okay. So yeah, do remember high resolution, because they are A1 size. They're bigger than your monitors, unless you have a really big ass monitor. Should be pretty. Okay. So thanks everyone. So that's all for today. Thank you.